Ladies and gentlemen, welcome back to our channel, MotoMouth, where we talk about a lot of things to do with driving, auto mechanics, and everything that you meet on the road and off-road. Once again, we have our resident engineer, Ivan Chibuka, who is going to explain to us about automotive systems. And with automotive systems, he is particularly going to talk about electric ignition. Again, as I always say, for some of us, the ordinary citizens, we don't think so much about these things. We just know that you put in the key and the engine starts, making noises. Or with the modern cars now, you push to start, which is a funny description because it is, if you put it in Luganda, it means Sindikanja, which is for the cars that are problematic, that we need to have to push down the hill and then we just jumpstart them. So yes, Ivan, you're welcome once again.
Okay, thank you very much, Mr. Alan Senyonga. I think we shall get down to business straight away. Today, like you said, we are going to look at electronic ignition systems. I'm going to try to share my small presentation here.
Yes.
Yeah. Can you see that?
Yes, I can see it.
Yeah. So we are going to discuss electronic ignition systems. When you talk of ignition, people talk about in Luganda tujita ignition okuba selefwe, starting the engine. In technical car speak, the ignition system has to do with how the fuel is ignited, how the petrol fuel, and in some cars that use LPG, some cars use gas, by the way, and some cars also use ethanol. So either petrol, LPG, or ethanol, its ignition requires for it to burn, for it to get an explosion. It can burn with any, in many conditions, but the conditions inside the vehicle engine requires precise timed ignition of the fuel. So they use ignition systems. Ever since the petrol engine was, I don't know if the correct word to use is discovered, but ever since it came into existence, the engineers always design some form of controlled ignition, a controlled way to start a fire. You know, to run an engine, there are many explosions going on inside the engine to give you the propulsion, the power propulsion, but those explosions are very finely controlled. So earlier systems were not exactly electronic, although they produced spark, they produced electricity. But beginning around the 80s, I think, and the early 90s, electronic ignition systems started to become common. So, like I mentioned, the function of this system is to supply a spark inside each cylinder near the end of the compression stroke to ignite the compressed charge of air fuel vapor. So now you can see an image of an early electronic ignition system. On this end here, you have the source of power, which is a battery, but when the engine is running, the electricity will be coming from the alternator or dynamo in older cars. The battery will supply power when the engine is not running. Once the engine is running, the alternator takes over There will be power coming through the ignition key because the ignition key is in the on position now. It will power the coil, but for the coil to work, it will require a ground. For electricity to flow, it flows from the positive to the negative. I will not go into the details of electricity, but for any current to flow, you need to have a path. So the path can only exist when there is a difference in potential. One side has to be high, the other is low. Positive is high, negative is low. Once you connect them, flow of electricity or current will start. When you disconnect them, there will be no flow, even though one remains higher than the other. Once they are not connected, there will be no flow. In short, the design of the coil is such that there is always power coming from the positive battery terminal. It's always there. It is the negative side which is controlled by some electronic form, a computer or otherwise, that switches on the negative on and off, on and off. And in so doing, it creates sparks back and forth, back and forth. But those sparks are timed. In the earlier systems, which use the distributor like you are seeing on the right here at the bottom, the engine would be turning, and then because the distributor would be timed on the engine, it would cause a switch inside the distributor to turn the control of the ignition coil on and off, and then cause sparks as and when the sparks are timed to happen. In short, that is what would happen. But again, the spark, for example, in a four-cylinder engine, you'd have 4 spark plugs. But you would have only one coil. So it means the coil would distribute its spark to each of those 4 spark plugs. So that's why you get the distributor arrangement here. So for every 1 revolution of the engine, the coil would work 4 times, but each time the spark would go to a different spark plug. And that would be ensured by the distributor. So there is a lot of coordination and timing going on here inside this system, because it is the one which tells the control of the spark, the ignition coil to turn on and off at what time, but also it is the timing the sparks directing the sparks to the respective spark plugs. I won't go, of course, there are more details than that, but I won't go into that here. Then after that, from around 95, 96, we began to see distributorless ignition systems. That rotary part of the distributor was taken out and everything became electronic now. There was little mechanical input, except you have the crank and cam engine position sensors on the engine. They would inform the computer, and then the computer would command this distributorless ignition system accordingly. So this system uses a special type of ignition that outputs the spark, to the spark plugs without the need for a distributor. Like I've just said, and the basic principle is that there is a loss spark, as in each coil on this spark was responsible for 2 spark plugs. So it would be connected in such a way, it creates the spark at the same time, but on the one time, there is a cylinder that is on the power stroke, and the other is on the induction stroke. And then the next time that coil fires, those cylinders have reverse roles. The one which was on the power stroke is now on the induction stroke, and the one which was on the induction stroke is now on the power stroke. And for that reason, you'd have 1 coil per 2 cylinders. So the example of the image I'm showing you here is an example of a 6-cylinder, probably V6 ignition coil system. If you had 4 cylinders, like most of the small petrol cars we have in the country, you'd have a coil, you'd have 2 coils. So it was called the DIS. distributorless ignition system. And that lasted, it's typically in cars from around 96 up to about 2004. Between 2004 and 2007, they began to phase it out and transited to the current direct ignition system. Now, with this one, it is similar to the previous one, to the distributorless ignition system, except that every spark plug now has its own coil. They are no longer, no spark plugs, no two spark plugs are sharing a coil. So it's called the direct ignition system, and it uses a coil for each cylinder mounted directly on the spark plugs. That's why some people will call it the COP, coil on plug system. When a mechanic tells you, oh, motoka na COP, that's what they mean. So in this case, you have the computer controlling each coil separately. There are transistors inside the computer. Sometimes the transistors are in the coil itself, the coil pack itself, just on top of the spark plug. And then you have, if you can see where my cursor is moving about, that would be the control of the plug, and that's where the coil is. And then you have this lower here is the boot, and then the spark plug fits into the boot. And now the spark itself is composed of a center electrode. Most of you have seen these spark plugs. Yeah, but it's composed of a center electrode, which is quite long. It connects the terminal. This is where at the top is where the coil will make a connection, the coil that is delivering the spark, and it will produce very, very high voltage. That voltage will be transmitted. The rest of the plug is mostly to transfer the voltage down to the tip here, the center electrode here at the bottom, or to insulate the electrode from the block of the engine to make sure none of that voltage, because it's very high voltage, it can leak very easily. It's such high voltage that it can jump an air gap, a carefully designed air gap here at the bottom. If you mess up with this gap, you are going to affect the strength of your ignition spark plugs. So it's in short, what is happening is that the ignition coil is creating a voltage high enough to jump across air, very, very much like lightning does, very, very much like the lightning you see during a storm. It can create voltages similar to what lightning produces. If you have played with these spark plugs in the vehicle, you have probably been electrocuted like I have been. Sometimes you tell somebody to crank the engine for you as you are watching something, you forget you are handling this spark plug or the coil, and it gives you, and you jump or you cry, whatever you choose. But yeah, it can electrocute kabisa. You can survive, yes. It's quite a bit different because the voltage is very high, but the current the power in the electric discharge is not that much. That's why you can survive, which is kind of different to if you went and got hit by lightning, or you were electrocuted by electric cables, or you started playing around with hybrid or electric car cables. The current that those cables carry is very high. That's why it can kill you. It is the current which kills you, not so much the voltage. Yeah, I don't want to go very much technical, but in short, that's how the ignition spark system on cars works. This system is, like I mentioned at the beginning, specifically used mostly by petrol cars, but also cars which use LPG and also ethanol and the other fuels which are very similar which have very similar characteristics to petrol, not diesel or heavy fuel oil for that matter. But some cars use I think there are cars which use biofuel, or they call them flex fuel cars. I've seen some in the USA, which use a mixture, whether you have ethanol or you have petrol, they can work. I've not seen many cars that have been converted to use LPG here in Uganda, although I've seen them in the UK. I also saw a few in Tanzania and in Kenya. We may have them in Uganda, but I've not been able to come across one. But I know they have them in Kenya and Tanzania. A lot of the Uber guys have installed LPG tanks. Ethanol, I've seen it being used in the USA, and I think Canada. Yeah, and the UK, yes. Yeah, so in brief, that is my presentation. It's a form of introduction to electronic ignition systems. I don't know if it has interested you enough. I don't know if you have any questions to ask about that.
Of course, my questions would be on the outside, what we meet, when you put the key inside, and the car takes some time when it is making that noise, versus the new technology of the push to start. And maybe you could also explain what happens when the car is being jump started, and what the physics behind that.
Yeah. With regards to whether you are using the ignition key to turn or you are using the push button to start the engine, there isn't a big difference. It's just psychological to you, the user, that I'm simply pressing a button and this car will crank until the engine starts. With most of those systems, you press once, the engine starts rotating, it starts cranking. Once the engine starts running, it will stop cranking by itself. You don't have to intervene again. The only times you may intervene is if you press the button to start cranking and the engine doesn't start. The computer will continue cranking the engine because the computer now takes over from you. It will continue to crank the engine for a set time, maybe 30 seconds. It reaches a time when it cuts it, or sometimes you intervene by pressing that button again, just like you would do the same thing if you are trying to pull back the key, if you are using the usual mechanical key to start. So it is intended that the engine starter, that motor, it does not overheat. Even the cables running from the battery to the starter motor, they overheat because the starter motor is the one item that takes the most current. It's the heaviest user of electricity on the vehicle. Nothing beats it. That's why when you are cranking, if you've noticed, everything else will stop working. Even lights will go off. The system is doing it in such a way that all the electricity, all the power from the battery, priority for that power is given to the starter motor. So the difference between you turning, there are some cars like Mercedes, they still have that key, but with it, you can, for you to crank it, you simply have to put it in the start position, release it, it comes back, and the engine will crank until it starts. So it is similar to a start button. There is no real magic. The other main difference is that with the stop-start system, the immobilizer activation or deactivation of the immobilizer system is included in the push button, typically, for most vehicles. That's how it is. Otherwise, I'm sure you have seen some people who retrofit those engine start buttons, even in older cars. I'm saying all this just to show you that there isn't much difference between you pushing a button and you turning. The whole idea is that some switch is closed to send a signal to the ignition motor to start turning. That's all. Whether you press a button or you use a foot to kick, in the past, at the beginning of vehicle vehicle manufacturing, there weren't even starter motors on cars. If you've seen old movies, somebody would go and in fact, that's why they call it a crank. Somebody would go to the front of the engine. Sometimes there were airplanes and do that thing. There was a handle which they would turn, and that was dangerous. You had to do it. You had to be very alert because once the engine started, this handle could now hit you. So you had to know exactly when to release, when to get your hands off that cranking handle. Otherwise, it could take you with it, or it could hit you. I think I also read somewhere the Formula One cars, because they are trying to take any what they consider unnecessary weight off those vehicles. Do you know they don't have those starter motors? They don't. They don't have starter motors, so they have to be cranked in the workshop, and then they are driven on the track. So if you stop on the track, if you've seen races, Formula One races, when somebody's engine dies on the track, they have to be towed because they cannot restart the engine. Yeah, and they do that because even if it is 1 kilo or 2 kilos of weight that they are removing from the vehicle, it makes a big difference in considering the competition they go through. Another type of vehicle that will not have ignition starter, ignition motor, or starter motor is the hybrid cars. The hybrid cars use the motor, the motor which drives the car. Hybrid cars, at least the Toyota style, you can drive the car when the battery is charged enough. You can drive the car for some distance without the engine running. So they behave like electric cars. So that motor which drives the car when the engine is not running is the same one which cranks the engine. So they don't have the normal starter motor that you are used to. Yeah, and then what was your other question about?
Pushing the old pushing to start to jump start the car.
Yeah, that you can only do that on
manual cars. I think.
On manual cars. I've done some research. I read somewhere it is possible to do it even on an automatic car, but because of the way the automatic gearbox is built, one, you'd be ruining the transmission, but two, you also have to reach quite high speeds. With a manual car, 10, 15 kilometers an hour is enough for you to do that jump starting. But with an automatic, you need to do at least 80 kilometers an hour for you to be able. And now when you do it at that speed, you are going to be hammering the transmission. Yeah, but I've heard that it is possible, but it's not advisable on automatic cars. Even on manual cars, you wouldn't advise it, especially in an emergency. Yes, when you are stuck somewhere, but just note that you can ruin the gearbox. You can also ruin the transfer case when the vehicle is heavily laden, like those lorries. If you've noticed, lorry drivers usually avoid doing that when the vehicle is loaded. They can attempt it when the vehicle is empty. Yeah, so that is the comparison. But of course, the topic was about the ignition spark system, but that one will be turned on the moment the key is in the on position. The coil, the ignition coil, is just waiting for control to start producing the spark. And that control will start coming the moment either the engine is running already. No, yes, when the engine is running, but also when it begins cranking. The moment the engine begins turning and the engine computer sees that the engine is turning, it will begin to provide the coils with the instructions to provide sparks. And that's how the engine will run. As long as the engine is running, you see ignition sparks. The moment the engine dies, even if the switch is in the on position, the computer knows the engine is not running because it can see from the sensor that the engine is not rotating. And the cam position sensor and the crank position sensor help the computer to know exactly in which position every part of the engine is. It knows which cylinder is at top dead center, which one is on compression stroke, which one is on induction stroke, which one is on exhaust stroke, and it gives instructions accordingly. So there is fast, very, very fast calculations going on here. Too fast for you even to see with your eye. Yeah. We have I think about 5 minutes left. I don't know if you have any other questions or comments.
The last question would be this thing we used to see a lot in movies, where someone opens the car and then pulls some wires from under the steering wheel.
and is able to start the engine.
Eh,
It's possible, but on all the cars. In newer cars, when you see a movie showing you something like that, that is real fiction, because in newer cars from around 2005 onwards, there are very, very few cars without an immobilizer system. So whereas you may get to the wires which give the instruction to crank the engine will crank, but the engine will not run. It will crank but refuse to run. Why? Because it doesn't have the right key. The right key will give the right immobilizer code for the engine to accept running, or rather for the computer to accept running the engine. Without that, in newer cars, that's fiction. It's no longer possible. And I hope the guys who make movies are adjusting with the times. They should stop showing us that it's possible, I think, in older cars. We used to see it all the time. Remember the old taxis we used to ride in primary school? Somebody would not have a key. They would just come and they put some wires together and the thing would start. Possible on all the cars. In cars with the mobilizer systems, there is much more that goes into starting the car than you think about. Everything about the immobilizer system happens so seamlessly and so automatically that you never even realize that the key has to be the correct one for the computer to accept to run the engine. So if you still see it on new cars in movies, yeah, that's fiction. For cars from around 2005 onwards, most manufacturers, in fact, immobilizers started in the early 90s, mid 90s, thereabouts, in European brands mostly. Then we started seeing them in Japanese brands around 2000, 2001. The Americans were the last, I think. There is one brand, I think, which doesn't fit immobilizers up to date. I think it's Hyundai. Hyundai or Kia, one of them. That's why in America they say they are easy to steal, and even insurance companies have issues with that. But most other manufacturers have immobilizer systems fitted. And you'd need the right key to start the vehicle. We've now transited into, of course, we are now digressing, but we've now even progressed to keyless entry. Keyless entry is where you have the key. The vehicle I drive now, as long as I have the key on me, even if it is in the bag, when I approach the vehicle, when I'm about 1 meter away from the vehicle, the doors will open by themselves. You hear them opening, the lights will do that. So for some cars like Toyotas, you have to reach out to the handle, but by the time you pull the handle, it has already released the locks. But the Renault I drive, when I approach the vehicle, and when I stop it, when I stop the vehicle and walk out and walk away, it will lock by itself. I don't have to do anything. I simply walk away. When I'm within a distance of about 3 meters, you can hear the doors locking, and it will beep twice. For some cars, you may need to press a button to confirm that you are leaving, and then it will say okay. But that is the keyless entry. If you are still pressing the remote to open and close, no, that's not that's not keyless entry yet.
Okay,
Yeah.
thank you very much. We
You're
have
welcome.
learned more, signed up for.
Yeah. Thank you very much for this, and I hope to see you and our viewers another time.
All right.